Okay, welcome. Today we're going to talk about the graphs of sine and cosine functions, and our objectives are to sketch the graphs of sine and cosine functions. Please feel free to stop or pause the video at any time so that you can take notes. Okay, we're going to talk about the graphs of sine functions, and we're going to start out with the basic or the parent function of y is equal to the sine of x. And if I were to make a table of values where I made x 0 and pi over 6 and pi over 4 and pi over 3 and pi over 2 and pi, then I would end up with a graph. Put pi in here because it's not showing up very well. I would end up with a graph that looks like this. If I made a table of values, a t-chart, and I graphed all the points, then I would end up plotting the points, and then my graph would look like this. Now, once I got to 2 pi, the values would start repeating again. So then I would just take this whole shape and section here, and I would replicate it from 2 pi to 4 pi, and I could replicate it again from 4 pi to 6 pi, and I could go backwards. So you have to always dash off because these are infinite graphs, because I can plug in all the values from negative infinity to infinity. That's why the domain is all real numbers. So I have what's called a period of 2 pi, which means after I go a length of 2 pi, then all the values start repeating in the same order. And you'll notice with the sine graph, I have 5 critical numbers. I start at an intercept, and I go to a maximum value. I go to an intercept. I go to a minimum value. I go to an intercept. All right, so there would be 5 critical numbers, because what I don't want to do is I don't want to have to make a t-chart of values every single time I go to graph. So we'll learn the shape of the parent function, which this is the shape of a sinusoidal wave. Right? It starts at, like we said, an intercept, maximum, intercept, minimum, intercept. And unless I do a transformation to it, it's going to look like that. And you'll notice that my maximum y value is 1, and my minimum y value is -1. So my range is from -1 to 1. And and because the period of sine is 2 pi, we'll graph from 0 to 2 pi, but sometimes in classes I'll make you graph 2 periods instead of just 1 period. And the rest of the graph is made up of repetitions of this portion. So one complete cycle of a sine curve includes 3 x-intercepts, 1 maximum point, and 1 minimum point, and that gives me the 5 critical values. What you notice, the 5 critical values divide the whole period into 4 equal sections. Right? So you'll notice that intercept, and then the middle point I have another intercept, and at the end point I have an intercept. And the midpoint between these two intercepts, I'm going to have a maximum and a minimum. So here's all the things that I could possibly do to a sine graph, all my transformations. So if I have a parent function y is equal to the sine of x, then if I multiply something outside the function, I know it's going to have a vertical transformation. If I multiply something inside the function, I know it's going to have some type of horizontal transformation. Adding or subtracting inside the function is going to have some type of horizontal transformation, and adding or subtracting outside the function is also going to have some type of horizontal transformation. So the first thing we're going to talk about is multiplying something outside the function. And if I multiply something outside the function, it changes the amplitude. So let's go back to the sine graph. When we said here that the range of the function was from -1 to 1, well, you'll notice that from equilibrium, which is this axis of oscillation here, the highest value I go up is 1, and the lowest value I go down is 1. So that's actually called the amplitude. So the amplitude of the parent function is 1. So if I multiply something outside the function, I'm going to change that. If the absolute value of A is greater than 1, then I'm going to have a vertical stretch. If the absolute value of A is less than 1, then I'm going to have a vertical shrink. Now, the reason why we take the absolute value is because if I have a negative, it's not going to stretch or shrink the graph. It's just going to cause the graph to be a reflection. We're also going to talk about graphs y is equal to, here's an amplitude change here for A, sine b of x. Now I'm multiplying inside, which multiplying inside the function is going to cause it to stretch or shrink horizontally, which is going to change the period of my graph. So the amplitude is still going to be the absolute value of A, but now I'm going to have a period of 2 pi, because my original period is 2 pi, divided by B. So whatever number is multiplied by x, whether it's in parentheses or not, it's still multiplied by the x, is going to change my period 2 pi divided by that value. So let's graph one. I want to determine the amplitude and the period of each function, and then I want to graph one period of the function. So if I have y is equal to 1/2 sine of x, then my amplitude is 1/2, and my period is 2 pi because the number in front of the x is actually 1. So I'm not changing anything because 2 pi divided by 1 is 2 pi. So I'm going to find my critical values. Well, what's in here, this is really bx minus c. Okay, so, which by the way, if I only have x, I'm always just going to go from 0 to 2 pi anyway, because b is 1 and c is 0 in this case. If I'm looking at the original function, if I compare it to everything I can do, then bx minus c, if this is just x, then b is 1 and c is 0. So if I am not changing, multiplying anything by the x or adding or subtracting anything, it's always going to go from 0 to 2 pi. Now remember, I have to have 5 critical values, and the 5 critical values, I'm going to have an endpoint at 0, I'm going to have an endpoint at 2, because it's not shifting left or right or anything. And then the midpoint between 0 and 2 pi is just pi, and then the midpoint between 0 and pi over 2 is 0 and pi is pi over 2, and the midpoint between 0 and 2 pi is 3 pi over 2. That's one way to look at it. Another way to look at it is I could start at my endpoint, and since my period is 2 pi, I can take and add 1/4 of 2 pi. So if I take and add 1/4 of 2 pi, I'm going to start at 0. So I take the period, divide by 4, 2 pi divided by 4 is pi over 2, 0 plus pi over 2 is pi over 2, plus pi over 2 is pi, plus pi over 2 is 3 pi over 2, plus pi over 2 is 2 pi. I don't care which method you use, finding 3 midpoints or taking a quarter of the period and adding it to the starting point. That really is up to you, as long as you do it correctly. So when I go to graph, my highest value is going to be 1/2, my lowest value is going to be 1/2 because I don't have any vertical shifts. So I know that the parent function has an intercept, a maximum, an intercept, a minimum, an intercept, and then I draw a nice smooth curve, and I make sure I dash off on both ends in the direction the graph is going, so that I indicate that the graph goes on in this manner forever from negative infinity to infinity. Make sure you also put your 5 critical numbers on your graph. So you notice I have marked my scale over here, I put my 5 critical numbers on the graph, and then I've sketched my graph using my 5 critical numbers and my knowledge of the parent function. So why don't you take a second and see what you can do, well, at least determining the amplitude, because the amplitude is 1, but see if you can determine the period for y is equal to the sine of 4x, because in this case my 4 is my b. And our formula tells us that the period is 2 pi divided by b, so my period is is pi over 2. Now if I want to find my start point and my end point for my graph, I'm going to take whatever's inside the function, so bx minus c is actually just 4x, and we'll set it between 0 and 2 pi because that would be my original period if I didn't have any transformations. And then I solve for x, so I'll divide 0 by 4 and I'll divide 2 pi by 4. So that means my graph only runs from 0 to pi over 2. So my start point is 0, my finish point is pi over 2. Now I can take 0 and add pi over 2 and divide by 2 or multiply by 1/2, I get pi over 4. And I can take 0 and add pi over 4. I get pi over 4 multiplied by 1/2 or divide by 2, I get pi over 8, and then find the same midpoint here, adding these two values together and multiplying by 1/2. That gives me my 5 critical values. Or I could take 1/4 of pi over 2, which is the length of my period, which gives me pi over 8, and I'll start with my beginning point, which is 0, and 0 plus pi over 8 plus pi over 8 plus pi over 8 plus pi over 8, and it will still give me the same 5 critical values. So my amplitude is 1, I have my 5 critical values, I know the shape of my sine graph, so I can sketch the graph, making sure I place my 5 critical values on my graph, and then making sure I oscillate between 1 and -1, and dash off in both sides. So now I have y is equal to 2 times the sine of 1/3 x. So my amplitude is 2. My period is 2 pi divided by b, which is 2 pi divided by 1/3. And when I flip and multiply, I get a period of 6. Okay. Now I'm not going left or right, so I'm going to start at 0, and I'm going to go to 6 pi. And in the middle I have 3 pi, and in the middle I have 3 pi over 2. And between 3 pi and 6 pi, I have 9 pi, and I divide by 2. That's my 5 critical values. I mark my intercept, maximum, intercept, minimum, intercept, and then I draw my nice smooth curve, a little lumpy in my case, but nice smooth curve, and I dash off on both ends to show that the graph goes on and on forever. Okay. In this case, since I didn't mark my scale, it's understood that each tick mark is 1. Okay, so now I have y is equal to negative 2 times the sine of pi x. Well, the negative here, my amplitude is only going to be 2 because it's the absolute value of a. But the negative tells me a reflection. So instead of going from an intercept to a max to an intercept to a min to an intercept, I'm going to reflect it over the x-axis, and I'm going to go from an intercept to a min to an intercept to a max and an intercept. And to find my period, I'm going to take 2 pi and I'm going to divide by pi because that's my b. And 2 pi divided by b is just 2. I don't have any transformations left or right, so I'm going to, if I take pi times x and I stood up between 0 and 2 pi, I'm going to end up starting at 0 and ending at 2. And then the midpoint is 1, the midpoint is 1/2, the midpoint is 3/2. Or you can take 2 and divide by 4, which gives you 1/2, and you can say 0 plus 1/2 plus 1/2 plus 1/2 to 1. The ones here kind of got behind the graph. 3/2 and 2, and then plot your points, making sure you keep the reflection in mind, and then draw a nice smooth curve and dash off in the proper direction. Right. So now we're going to talk about phase shifts. So I still have A, absolute value of A is my amplitude. I still have B, 2 pi divided by B is my period. Okay, but Bx minus C, if I have some C in there, either a plus or a minus, because really if I have a plus sign in here, then I have to take a negative value, right? That causes a horizontal shift so that the starting point of the cycle is shifted from x equals 0 to C over B. Because of minus sign here, be sure and change the sign of the value when you pull it out. And C over B is called the phase shift. So a phase shift is a horizontal shift. If C over B is positive, then I'm going to shift to the right, and if C over B is negative, I'm going to shift to the left. And the way that I think that we should find the 5 key points is you take your B over C, your Bx minus C, and you set it between 0 and 2 pi, which is a common way of doing it, and then you solve for x. So I'd add C to both sides and then divide by B. That's going to give me the endpoints, and then I would find the 3 midpoints. So suppose I want to graph one period of each function. I'm going to include the amplitude, the period, and the phase shift. So I'm going to start with y is equal to 4 times the sine of 2x minus pi. Why don't you take a second and see if you can pick off the amplitude, the period, and the phase shift. The amplitude is 4. The period is 2 pi divided by 2. And see, C is really just pi, because remember it's minus C. So it's minus pi, so C is pi, divided by B, which is 2. So my phase shift is pi over 2. So my whole graph, since this is positive, is going to shift over to the right, pi over 2 units. So when I go to find my critical values, I'm going to take pi over 2. Okay, I'm going to add my period of pi to it. So pi over 2 plus pi is 3 pi over 2. And then I will find the midpoint, and I will find the midpoint and the midpoint. My amplitude is 4, so I know that I don't have a reflection, so a sine graph starts at an intercept, goes to a max, goes to an intercept, goes to a min, goes to an intercept. So making sure I go all the way to my amplitude of 4, I put in my points, and I sketch my graph, and then I dash off on both ends. So notice my graph didn't start over here, it started at my phase shift of pi over 2. And then I took pi over 2 and I added pi, which gives me pi over 2 to 3 pi. So if I wanted to go ahead and show the work, I could take 2x minus pi, set it between 0 and 2 pi. Then I'll add pi to both sides of the inequality, and then I will divide everything by 2, and I'll notice that I start at pi over 2 and I finish at 3 pi over 2. Okay, so if you're having trouble finding your critical numbers, the following slide should help you out. So remember our rules for the sine graph, and of course it'll be for the cosine graph also. down here at the bottom it says that x values for the 5 key points start with, and I take 0 less than or equal to bx minus c, which is the values that are inside the function, and put it between 2 pi, and that will give me the endpoints if I solve for x. This is the period of my initial graph. If I don't have any transformations for sine or cosine, then I'm going to start with 0 and end with 2 pi. But if I have a B or a C, then it's going to change. It's either going to stretch or shrink the graph horizontally, so I'll have a period change, or it's going to shift it horizontally, which means I'll have a phase shift. So if I take bx minus c and I put it between 0 and 2 pi and I solve for x, that's going to give me the endpoints, and then I can find the 3 midpoints using one of the 2 methods that we discussed previously. So let's go back and consider y is equal to 1/2 sine x. Okay, so this is the start point of an initial period and the end point of an initial period. So I can go ahead and do that. Since I don't have anything inside sine except for the x, then bx minus c is just x. So I'll take 0 and put it between, I'll put x between 0 and 2 pi. Of course, it'll equal to that. And then, of course, it would repeat over and over again. And that would be my beginning points. So I'm going to start at 0 for my 5 critical values. I'm going to end at 2 pi. And I need to find the other 3 critical numbers. So I can use either method. One method we talked about is using the midpoint method. Okay. So what I will do is I will start with 0 and 2 pi. And then I'll take 0 and 2 pi and I'll add them together. And I'll either multiply by 1/2 or divide by 2 to find the midpoint. Easier to multiply by 1/2 if I'm dealing with fractions, so I'll just stick with that method. And so the midpoint between 0 and 2 pi is pi. So that is my critical value in the middle. And then I'm also going to average the other 2 values. So if I take 0 and pi, and I average them, 0 plus pi, multiplied by 1/2, which is the same thing as dividing by 2, and the number here for my second critical value between 0 and pi is pi over 2. And then I'll do the same thing. I'll take pi plus 2 pi, and I'll average it out, and that will give me my last critical value of 3 pi over 2. So now I have my 5 critical values: 0, pi over 2, pi, 3 pi over 2, and 2 pi. And those are the ones I'll put on the graph when I'm graphing for my initial period for the graph that has a transformation. The second method is I'll start with y is equal to 1/2 sine x, which of course x is still my bx minus c. And what I see here is that b is 1 and c is 0. So my start position is 0 because I don't have a phase shift here. There's nothing inside there but x. And I can also see that I'm going to start at 0. And my period is 2 pi because b is 1. 2 pi divided by 1 is 2 pi. And so I'll find 1/4 of the period, and 1/4 of 2 pi is equal to pi over 2. So then I will start at my first critical value, which is 0, and I'll add 1/4 of the period 4 times so I can get my 5 critical numbers. So 1/4 of the period is pi over 2. I take 0, I add pi over 2, I get pi over 2. I take pi over 2, I add pi over 2, I get pi. I have pi, I add pi over 2, I get 3 pi over 2. I have 3 pi over 2, I add pi over 2, I get 2 pi. So either method works well, whichever one you prefer, and I don't care which one you do as long as you do it correctly. Well, that's all well and good if I don't have a phase shift or a period change, so let's consider another one. Let's go back and consider y is equal to 4 times the sine of 2x minus pi. So here's my bx minus c. Okay. Now, if I didn't have any transformations, my starting point would be 0, and my finish point or my final point of the initial period would be 2 pi. But I put bx minus c in the middle, and I solve for x. So I'm going to add a pi to both sides of the inequality to get it out of the center. I'm going to divide by 2. Okay. So now I have a new starting point of the initial period for this specific function right here of pi over 2 and a finish point of 3 pi over 2. I can use any method to find the other critical values. Method 1, I find my start and my end point, and I lay them out. And then I average. So I'll take pi over 2 plus 3 pi over 2, and I'll multiply by 1/2. And that gives me a middle critical value of pi. So then I'll take pi over 2 plus pi, multiply by 1/2, which gives me 3 pi over 4. And I'll take pi plus 3 pi over 2, multiply by 1/2, because it's the same thing as dividing by 2, and I'm averaging. And that gives me a critical value of 5 pi over 4, and there are my 5 critical values. If I use method 2 for y is equal to 4 times the sine of 2x minus pi, then I'm going to start with my first critical value, which is c over b. And remember, this is minus c because it's b. It is bx minus c. So c is I have to always change the sign here for my c. So my c is pi, not negative pi. Had this been a plus, I'd have to say negative pi. So c over b is pi over 2. So that's my phase shift, and that's my first critical value. Then I find my period. My period is 2 pi over 2 because b is 2, so I have a period of pi. And then I take a quarter of that period, so 1/4 of pi is pi over 4. And I'm going to start at pi over 2, and I'm going to repetitively add pi over 4 to get all the critical numbers. So pi over 2 plus pi over 4 plus pi over 4 plus pi over 4 plus pi over 4, and that's how I get all the critical numbers. So hopefully if you were having some trouble with that, that's been helpful for you. All right, so let's try to graph y is equal to the opposite of sine of 2 pi x minus pi. Why don't you see if you can find the amplitude, the period, and the phase shift? Okay, the amplitude is 1. The amplitude is not -1. The negative tells me that there is a reflection. And the period is 2 pi divided by pi, so the period is 1. And then if I take pi and divide by 2 pi, make sure you change the opposite. So if this was a plus sign, I'd take negative pi, but it's a minus sign, so I'm take positive pi. And so pi divided by 2 pi is 1/2. So if I take 2 pi x minus pi and I set it between 0 and 2 pi, then I'm going to get endpoint values of 1/2 and 3/2. Or I could start at 1/2 and go a whole shift of 1, so 1/2 plus 1 is going to give me 3/2. I could take the 1/2 and divide by 4, and I'd take 1/2, add 1/4, add 1/4, add 1/4, add 1/4 would give me my 5 critical numbers. Or I could start at 1/2 and finish at 3/2 and then find midpoints. It's up to you. Make sure that you do a reflection for the negative. So I'm going to start at an intercept, go to a minimum, go to an intercept, go to a maximum, go to an intercept, draw a nice smooth curve, and then dash off on them. So if I did a table of values for a cosine function, then I would notice that the cosine of 0 is not 0 like a sine function, it's 1. And then I could take and put in the values, and I will see that my parent function now for one period, which is still 2 pi, the period is still 2 pi, it now looks like a soup bowl more than it does that little graph that would before. So I still will have 5 critical values, but this time I'm going to start with a maximum, go to an intercept, then a minimum, and then an intercept, and then a maximum. Of course, then I would dash off in both directions to show that the graph went on and on forever. So when I graph y is equal to the cosine of x and I list points on the graph using a t-chart, I will find that, of course, that the values start repeating in the same pattern after 2 pi. So we know that one period is going to be from 0 to 2 pi as long as there's no transformations, and then the rest of the graph is repetitions of those. The domain is all real numbers, and the range is all real numbers between -1 and 1, just like with the sine. Later on, when we talk about odd and even functions, we'll cover this part right here. And the graph is symmetric with the y-axis if I went on from a -infinity to infinity. So the graph of the cosine function, instead of starting at an intercept, going to a max, going to an intercept, going to a min, going to an intercept, where I had 3 intercepts and a max and a min, now I have 2x intercept, 2 maximum points, and 1 minimum point. But finding those 5 critical values is the exact same process as when graphing the sine function. So here's everything I can do to a cosine function. I do need to make sure that, before I start graphing, that I do know the shape and the general schema of the parent function for cosine. So once again, max to intercept to min to intercept to max over my 5 critical values, just like I do with sine, but now a different schema of how to lay out the points. So if I have y is equal to a times the cosine of bx minus c plus d, a, b, c, and d all do the exact same thing to the cosine graph. I just have a different general shape for my parent function. The amplitude is still the absolute value of a. Negative is going to give me a reflection. The period is still going to be 2 pi over b. When I'm finding my 5 critical values, I'm still going to take bx minus c and set it between 0 and 2 pi to find my endpoints and my 3 midpoints. C over B is positive, the graph still shifts to the right. C over B is negative, the graph still shifts to the left. So everything as far as laying out the points, finding the critical values, are exactly the same between cosine and sine. It's just the way that I use those critical values. So suppose I want to sketch the graph of each cosine function, and I'll start out with y is equal to 3 times the cosine of x. I can find my amplitude and my period and my critical values. The amplitude is 3. Because b is 1, the period is 2 pi over 1. Once again, there's nothing here. I'm between 0 and 2 pi, so my 5 critical values, if I don't have any phase shift or any period change, so that's going to be the same from 0 to 2 pi, and find my 3 internal points for midpoints. Sketch my graph, so I lay out 0, pi over 2, pi, 3 pi over 2, and 2 pi. But now I'm going to start at a maximum, and my amplitude is 3, so I'm going to start at 3, and then I'm going to go to an intercept. I'm going to go to a minimum of -3. I'm going to go to an intercept and go to a maximum. And then this time I don't dash up, even though the graph looks like it's going up, because actually it starts to go back down. So I'll dash down on both ends to show that the graph carries on that way from -infinity to infinity. So let's look at, why don't you see if you can find the critical values and everything for y is equal to the cosine of 4x. The amplitude is 1. My period is 2 pi divided by 4, and this is almost exactly like the problem we graphed with the sine in the previous lesson. And I'll take 4x and set it between 0 and 2 pi, divide by 4, and I'll start at 0 and finish at pi over 2. So I can start at 0 and finish at pi over 2, and I can find the midpoint, and then I can find the midpoint, and I can take these 2 points and find the midpoint. Or I can say 1/4 of pi over 2 is 1/8, and I can start at my starting point of 0, add 1/8, add 1/8, add 1/8, add 1/8, and those are my 5 critical values. So I'll lay my 5 critical values on my graph: 0, pi over 8, pi over 4, 3 pi over 8, pi over 2. And my amplitude is 1, so I'll say, okay, I'm going to start at 1 because it is cosine, so always make sure you go back and check, because it's going to look the same as a sine until you start graphing it. And I'll go from a max, intercept, min, intercept, max, and then I'll dash off on both ends. So why don't you see what you can do with this one? All right. I have a reflection because I have a negative in front, and my amplitude is 1/4. Then I'm going to take 2 pi and divide by pi over 2 and flip and multiply, and I end up with a period of 4. So if I take pi over 2 times x and I set it between 0 and 2 pi, and then I multiply both sides by 2 over pi, because I'm going to multiply by the reciprocal to get rid of that, I'm going to have 0 less than x less than 4. So I'm going to go from 0 to 4. And since my period is the length of 4, I could say, okay, 1/4 of 4 is 1. I can go 0 plus 1 plus 2, plus 1 plus 1 plus 1, or I can take 0 to 4 and find the midpoints. I'll lay out my critical numbers on my x-axis. And then I want to say, okay, well, I have a negative here, so it's a reflection. So instead of going to a maximum, I'm going to go to a minimum. And then I'm going to go to an intercept, go to a maximum, go to an intercept, go to a minimum, and then I'll dash off in the shape that the graph would be going to. Why don't you try this one? Remember, everything works exactly the same as sine, except for the scheme of how you lay out your critical values. In this case, my amplitude is 4. My period is 2 pi divided by 2, so just pi. My phase shift is pi over 2, so it's positive pi over 2, it's 2 to pi to the right. So I could start at pi over 2 and add 1/4 of pi, so pi over 2 plus 1/4 of pi plus 1/4 of pi plus 1/4 of pi plus 1/4 of pi gives me my 5 critical values. Or I can take everything inside the function and set it between 0 and 2 pi and solve for x by adding pi to both sides of the equation and then dividing, both sides of the inequality, and then dividing both sides of the inequality by 2, and it gets me from pi over 2 to 3 pi over 2. Add them together, find the midpoint. Add these 2 values together, find the midpoint. Add these 2 values together, find the midpoint. Either way you do it, you get the same critical values. I lay them out on my graph. I go back and say, okay, it's a cosine. I I have an amplitude of 4, so I'm going to start at a max, intercept, min, intercept max, and then I will dash off on both ends. Now I'm starting with something different because now this minus 2 is not a c, it's a d. It's outside the function. And sometimes you'll actually see that in front of the value or after, but whatever ones, it's not in parentheses with the x, so it is not c. It is a vertical shift. Anything added outside of the function, whether in front or behind, is a vertical shift. So my amplitude for this one is 1. My period is still 2 pi. And since this is not inside the parentheses, it's a vertical shift of 2. I also might see it like y is equal to negative 2 plus the cosine of x. These are actually the same two equations, but in either case, the negative 2 is not inside the function, so it's a vertical shift down 2. So what I do when I do that, there's a couple ways you can do that, is I'll go ahead and sketch everything without the vertical shift. I'll go back and find my 5 critical values here and my period, and I'll lay out my 5 critical values on my graph, and I'll just dash in. This is one way you can do it. I'll just dash in the graph as if there were no vertical shift. And then I'll say, okay, that's minus 2. So I need to take this whole graph down 2 units. So this value here has to go down 1, 2 units. And this value here has to go down 1, 2 units. And this one has to go down 1, 2 units. So I'll take my axis here and I'll redraw it 2 units down. So I take the whole axis here, I go down 1, 2 units, and I'll draw another axis. I'll take this point down 2 units, this point down 2 units, this one down 2 units, and I'll oscillate around that new one. And so here's my final graph. That's why I make that solid. Another way you could do it is in the very beginning, just say, okay, minus 2, you don't have to even do this part here. Take your 5 critical values and just take your whole axis here and sketch it down here, and then go up sketch it here and then go up 1 from there, intercept, down 1 from there, intercept, up 1 from there. Whichever way you find the best, that's fine as long as you do it correctly. Okay, well, your assignment will either be posted or I'll give it to you in class. Have a great day. Thank you.